Solution. We'll take A. Current in the circuit is given by, our formula is electromotive force R plus small r. But we need to find small r is 0. Remember that small r is the internal resistance of the cell, and here the cell was given without internal resistance. Then our big R is the resultant or the resistance of these two resistors. So we are going to calculate that. Remember that the two resistors are in parallel. Remember that the two resistors are in parallel. So we use the formula 1 over R is equals to 1 over R1 plus 1 over R2, which is equal to 1 over 2 ohms plus 1 over 3 ohms. So we now have that 1 over R is equal to LCM of these two numbers here is 6. Then 2 go into 6. 2 go into 6 will give you 3. 3 plus 3 go into 6 will give you 2. So you have 5 over 6. If you make R the subject here, you're going to cross multiply 6 times 1 and 5 times R will give you 5R is equals to 6. Look at it. 5 times R and 6 times 1. You understand? We'll give you 6 here. Why 5 times R will give you 5R. Therefore, R is equals to, you divide here by, divide this by 5, divide this by 5. 5 cancel 5. R is equals to 6 over 5 is 1.2 ohms. So our R is 1.2 ohms. Then we'll substitute into the formula I is equal to, which is current, is equals to EMF of the cell over big R plus small r, which is equals to, the EMF of the cell is 12 volts over capital R here is calculated to be 1.2 ohms plus 0 ohms. So our I is equal to 12 over 1.2, which is equal to 12 divided by 1.2. If you press your calculator, will give you 10 ampere. So the current in the circuit is 10 ampere. Then let's calculate B. The question that was asked in the JAM question specifically was this B question. I added A in order to explain a concept. And what is the concept I want to explain? The concept is that if you are given a circuit diagram like this, and they are asked to calculate the current is, for instance, they say you should find this current in this circuit. This current is a current flowing in this wire from the battery. But if they ask you to find a current that flows in any of these resistors, because these resistors are connected in parallel, so the current that will go through 2 ohms and 3 ohms are not going to be the same. So you are not going to say that this current which is here, which you have calculated, the current on this wire here is the same as the current that will go through 2 ohms and 3 ohms. No, something happened. When this current gets to this point, if I call this point A, when this current goes to this point, it is going to split into two into the two wires. So part of it will go to 2 ohms, part of it will go to 3 ohms resistor. So you are going to discover that here now. So we are going to look for, say, current flowing through 3 ohms resistor. So we use Ohm's law. Ohm's law states that the potential difference is equal to current multiplied by R, by the resistance of the resistor. So if I make current the subject, it is equal to V over R. Now, in this case, we use V. V is what? V is the potential difference between these 2 points. And it is the same thing as the voltage from the battery. So we can now have that our current, the current that goes through 3 ohm resistor is going to be equal to, this V is 12 volts over R. R is what? R is 3 ohms. So you discover that if 3 goes into 12, it will give you 4 ampere. So it means that the current that goes through 3 ohm resistor is 4 ampere, whereas the current that is in the circuit, which is the current in this circuit diagram, which is this particular current here, is equal to 10 ampere. You can see it here, 10 ampere. So, but when this current gets to this point, what happened? 4 ampere goes to 3 ohms resistor, and the other remaining 6 ampere automatically goes through the 2 ohm resistor. So that is how to tackle the problem. Then you look at question C. Question C says you should calculate the energy developed in 5 minutes. C now. For us to find energy developed in 5 minutes, we are going to look at electric energy. The electric energy formula is given by IVT. In this, so that I have space. So we are going to use the formula for electric energy. Electric energy formula is given by IVT, or I squared RT. Don't forget, this I here represents current, V voltage or potential difference, T time. This current, resistance of the resistors, and T time. So if you watch the diagram, you discover that we've already calculated the current in the circuit, and we got the current to be equal to 10 ampere. And we know the voltage is given. And we are told that the time is what? 5 minutes. So we're going to say time is 5 minutes. And this 5 minutes is equal to 5 times 60, which is equal to 300 seconds. So the required time is 300 seconds. So we can use any of the two. And we've already calculated our R, which is capital R, which is the resultant or the effective resistance of these resistors, which we've done before. And we got that the effective resistance is 1.2. So any of the two can solve the problem. But let me simply use the first one. So electric energy is equal to IVT, which is equals to, I here is current, and current is 10 ampere multiplied by V 12 volts and T 300 seconds. So my E is going to be 10 times this will give me 120 times 300. Then 12 times 6 here is equals to 12 times 3 here will give me 36. Then bring these 3 zeros. So that means that the electric energy developed in the circuit is 36,000 joules. You are just watching my video for the first time, please do well to give this video a thumb. Like this video and share it with your friends. Thank you.